Hello everyone and thanks for joining my talk. Today I'll be speaking about the complex relationship between software developers and test code. I'm also going to suggest and mainly demonstrate with live coding how we as an industry can shift some of our assumptions and methodologies toward improving that relationship. Let us begin. My name is Tal Doron. I'm a software engineer, currently working at NICE, and actually have been doing so for the past decade or so. Mainly, I've been working with backend technologies such as Java, .NET, and of course Node. About 3.5 years ago, I've stepped out of the development teams and assumed the position of a technical coach, which means I go through almost every team in our R&D organization and teach a training which is called ASE, which stands for Agile Software Engineering, which basically covers in a very hands-on and intense way all the practices that we can see on the right, such as emergent design, clean code, refactoring, design principles and pattern, testable code, valuable test, TDD, and BDD. Today, we're actually going to focus on testable code, valuable tests, and TDD. Now, after I teach the training, I usually join the teams and work with them hands-on on their own backlog. And this way, we can see that we actually implement the things that we've done in class. So I want to start with the following question, okay? And that's a question for you, so try to think about your answer. How would you describe your feelings regarding writing automated tests? It doesn't matter if it's unit, component, or integration test, okay? Now, this question actually interested me quite a lot when I've prepared this session. So I've created the Google Forms and published it in many forums, and I got several hundred answers, okay? So think about your answer, and of course, this is a multiple choice question. So these are the options. A, I actually like it. B, I don't like it, but I understand the value of me writing them. C, I hate it, I don't write tests, it shouldn't be within the responsibility of the developers. Now, after several hundred of responses, the graph shows as follows. Now, this is a very surprising graph, so let's talk about it. About 45% of people say that they actually like writing tests, okay? 50% don't like it, but I understand the value, and about 5% actually hate it. Now, this is very surprising, okay? I was expecting different numbers altogether. So the first time I saw the graph, I thought to myself, you know what? No chance. Only 75% actually values the truth, and 25% are straight up liars. Now, the graph on the right, of course, is a joke, but I would expect about 80 or 90% of developers to say that they don't like writing tests, but they understand the value of it, okay? And not like almost 50-50. Now, I would say that it is a bit biased, okay? And the reason for that is, people that actually want to take a survey about testing probably have some affinity for testing, right? And this affinity actually has some effect on the response. So this is my guess. But even if not, okay, even if these numbers are correct, still as an industry, we have a problem. The problem is that about 55% of developers say that they don't like writing tests. Now, it's okay not to like something, but if we don't like something that we actually do quite a lot, and most organizations actually spend a great deal of time today in writing tests and increasing their quality. So if we do it quite a lot and we don't like it, so we tend to do it bad. So where's the love? So I would say that there are two main things, okay, that affect this relationship. On the left, the afterthought effect, and on the right, the unit effect. Let's start from the afterthought effect. So this illustration shows a daily stand-up, and I actually remember myself participating in a daily and saying the following. I've finished, okay, the feature is working because I've tested it in some way, but now I have only tests left to write. And you probably can relate, okay? And when I think about it today, it's actually pretty absurd. Why? Because it makes me a bit angry. Why? Because usually when I write tests after I write the code, two things happen. First, I need to rework my code. Perhaps I discovered that the code is not that testable, that I've missed some of the things, okay? And I need to rework on something that I actually already know that it's working. Second thing that happens when I write the test after the code, so the test code actually becomes a second-class citizen, okay? Which means that I treat it not as good as I treat the production code, okay? I do not adhere to design principle. The code is not very clean, and the code becomes not maintainable. Now, if the test code is hard to maintain, okay, and hard to develop on top of, so my entire code base actually becomes this way, okay? So this is a very important point. The test code should not be a second-class citizen. Another thing that the afterthought effect causes is the following diagram. Okay, we are always stressed out, right? We always need to deliver more and more value. We always encounter bugs that we need to fix, and we always need to attend many different aspects of the application, right? Now, sometimes we're so stressed out that we actually say, you know what, we don't have time to test. Okay, we have to deliver something, we don't have time to test. By the way, even if testing is part of the definition of done, sometimes the hard deadline is stronger. Okay, now having no time to test has its effects, right? It causes software defects. If I do not test my software, yeah, I probably am missing something, right? And these defects actually cause a direct link to load and stress, okay? And this is a very vicious cycle, and I want to avoid it in some way. Now, another thing that it causes if my test suite is incomplete because I don't have time to test from time to time, so my trust in the test suite actually decreases, okay? Now, let's talk about the unit effect. Now, the unit effect has its own downside. Now, when people are asked what are unit tests, so they usually say we need to test for unit of code, the smallest units of code possible, such as a function, a module, class, or whatever, okay? And if a discussion rises, so usually people talk about the testing pyramid that you probably know. And this testing pyramid is a bit problematic because it says several things. First of all, as you can see in the base of the pyramid, we have unit tests, right? So it means that according to this arrow here, we actually need to have lots and lots and lots and lots of unit tests to test for small units of code, okay? Another thing that we can see from the arrow on the right, we need to test these units of code in isolation, okay? Now, it looks okay, but it actually adds like 4 other angry emojis to the picture, and I want to talk about them. First, if I need to test lots of units of code in isolation, I need to spend lots of my time in writing mock objects, right? Because this is the way that we can isolate. And nobody likes to spend lots of time writing mock objects, right? They are not real. Second thing, the quantity of tests rises. Okay, imagine a complex application that has lots of modules and lots of functions and perhaps lots of classes. It doesn't matter. Okay, if we need to test for every piece of code, so the quantity of tests becomes really, really massive. Now, the problem with quantity of tests that is massive, the testing for each unit of code, is that if I want to refactor my code from some reason, and I always want to refactor my code in order to adhere to a better design, in order to meet a new requirement, it doesn't matter. So refactoring becomes something which is known as refactoring hell, okay? We can be in 2 different scenarios, okay? We can say that, okay, we need to change the system, so we need to refactor the code in order to better meet the requirement. I can say the following. I can say, you know what, I'm going to refactor my code and everything is going to be okay because I have a safety net of tests. This is a great place to be in. The second scenario can be, you know what, there's no way that I'm refactoring my code because I'm going to have to change about 300 or 400 tests, okay? And of course, this is not the place that we want to be in, okay? Now, another problem with unit tests and with treating when testing for small units of code, when the test is very aware of the code structure, is that actually the unit test might pass, okay, and we can be very happy with it. But sometimes when we integrate the system, so things start to break because everybody knows that the integrations are pretty painful, right? So this gives me actually another decrease in my trust in the entire test suite. So I would say that these all angry emojis here are some of the main reasons the developers actually don't like writing tests. So comes along Kent Beck, okay, about 20 years ago or more, and says, you know what, there are actually 2 simple rules, okay, in order to solve that problem. First, you write new code only if an automated test had failed, okay? And second, eliminate duplication and refactor the code if needed before you continue. Okay, and he illustrates this mantra, which is the red-green refactor mantra that you can see here. And red is saying, you know what, when you start to develop something, so please write an example, okay, write a test that fails or even doesn't compile. Green, make only enough code for it to pass, okay? Committing, by the way, all the scenes necessary on the process. Green is not the phase where I think about the best design or the best code that I can. After the test is green, so I can refactor my code. This is where I think about the best design. I refactor my code, I run the test again to see that I'm still green, okay? And there's a logic behind this circle, okay? I want to provide an example to what I'm about to develop, okay? Then I make it pass because it's really hard to imagine what would be the best code to meet the problem. I want to think about the algorithm and about the things that I need in order to solve the problem. And when the code is already written, then I want to try and think about it, okay? This actually works much better, okay? So when I refactor my code on the last phase, so this is where I think about the best design, I refactor it, and if I went from green to green, so I know that I should be good, okay? Great, so I want to add 3 additional things to that, okay? First of all, a unit should be treated as a business flow, okay? The test should not care about the structure of code. This is very, very important, okay? If the test doesn't know about the structure of code, the code can be refactored as much as we want, and we always want to be able to refactor our code, okay? A mock object is only for external boundaries of the application. This is very important, okay? There is no rule of unit testing and then isolating everything. The rule only says that I want to have valuable tests that I can easily run and set up, okay? So if I want to mock something, it should be an external boundary of the application, and there are also rules for that, okay? What are external boundaries? Databases, IO devices, streams, other services, it doesn't matter, okay? But I never try to mock an internal layer of my application, okay? And that's important. Last thing, last rule, which is super important, the test code is as important as production code. And this requires some shift of mindset for many, many people. Many people tend to allow many like code sins to appear because it's test code and it doesn't matter, okay? But when the test suite becomes something which is very hard to maintain, hard to understand, and hard to develop on top of, so practically the entire code base becomes the same, okay? So test code is as important as production code, and I apply every rule I know about design or clean code and everything that I know on the test code as well as production code, okay? Now, I've talked about TDD. Now, in order to demonstrate TDD, I want to do a code kata. So if you're not familiar with the term kata, kata is a word from Japanese, okay, which means form. Now, if some of you have been practicing martial arts or seen movies, so it's actually from there, okay? So a kata is a sequence of movement that the martial artist does over and over and over again. And the idea is that you're doing something over and over again until it becomes part of your muscle memory, okay? And then, of course, if the real thing will happen one day, so your body will know how to react. So came along Dave Thomas and took this idea to the programming world, and he called it a code kata. So what's the code kata? A code kata is a programming exercise, not that difficult, okay, that everybody with some experience can solve. And the idea is to practice some techniques. So there are katas for TDD, and there are katas for refactoring, and there are katas for design patterns, and there are katas for introducing new features or new languages or stuff like that. And today I want to do a very famous kata, which is called the Bowling Kata, which was introduced by Bob Martin. So the Bowling Kata is a kata that actually tells us, please solve an exercise that will know how to calculate the result of a bowling game, okay? Now, for those who are not familiar with bowling, I'm going to introduce the rules very, very quickly. Of course, if you need to, please refresh, okay? So what's a bowling game? So a bowling game actually has 10 frames for each player, okay? And each frame has 2 rolls, okay? We roll the ball actually twice, okay? Now we have a very special frame, which is the last one, that we might have 3 rolls. Why? I'm going to explain in a second, because in the last frame we might have a spare or a strike, and then we have an additional roll in order to calculate the score. So how do we calculate the score? So the score of each frame is actually the sum of 2 rolls, which is pretty simple. If I didn't say so, there are 10 pins and we need to drop the pins, okay? So the sum of 2 rolls, the sum of the pins dropped in 2 rolls. Great. Now there's a special situation which is called a spare. A spare is when I roll the ball twice, and after 2 times I've actually dropped all 10 pins. So this is good for me. Why? Because I get a bonus for that frame, and the bonus is calculated as follows. Of course, it's 10 because I dropped 10 pins, and the bonus is the next roll. I mean, the pins that were dropped in the next roll. Great. Another special case is a strike. A strike means that I took the ball, I rolled it, okay, and in the first go, I've actually managed to drop all 10 pins, okay? So that's great, and the bonus for that is even bigger. So how do I calculate the score for a strike? It's actually 10 plus the 2 next rolls. And the two next rolls doesn't have to be in the same frame. If I've done a strike and then another strike and another strike, so the result for the first one, the score for the first strike would be 30, right? Because it's 10 plus 10 plus 10. Great. Now the maximum rolls in the game are 21, okay? Because 20 is 2 times 10, right? And I have an additional roll in the 10th frame if I've done a spare or strike or something like that. And the minimum would be 11. Why? Because imagine a game that I've rolled the balls 9 times, 9 frames, and I've done a strike, okay? And let's imagine that in the last frame, I've actually missed twice, okay? So whenever I do a strike in the frame, I don't have an additional roll because I've already managed to drop all 10 pins, okay? And the maximum score of a game, of course, is 300. Why? Because in the example that I just gave, if I'm doing strike and strike and strike and strike over and over again, so eventually it would be 30 times 10, which is 300, okay? And the minimum score is, of course, 0, right? Because I've rolled the ball and I've missed every single time, okay? Great. Now, I hope that you're starting to think about it. I mean, start to think if you would need to implement it. I mean, how would you implement it? Okay. And let us start. So our requirement is actually to have two APIs, okay? One API would be to have a roll method, which gets the number of pins, okay? So every time that the number of pins is dropped, so the roll method will be called with the number of pins that were dropped. And another API would be the score method, and the score is actually being called only in the end of the game, okay? This is to make the kata a bit easier. I don't need to know the score all the time. Only in the end of the game, someone will call the score API and will ask me to calculate according to the rolls that were taken before. Okay. Now, we're not going to deal with turns, like whose turn is it and stuff like that. Imagine that we have a module per player or something like that. Okay. So let's go to the IDE and start. Now, I want to do it using TDD, okay, because I think the TDD actually cancel the afterthought effect, okay, which we talked about in the presentation, okay. And also when I'm doing TDD and I'm thinking about business flow, so it almost terminates the unit effect as well. And I wanna demonstrate how I do it, okay. So I have a project here. This project is pretty empty. It only has some configuration for running tests using Jest, okay. So let us begin. So the first test would be what? So that's also always something to think about. I mean, the first test in TDD needs to describe something very easy, right? I don't have any code written yet, okay? So I don't want to take the hardest scenario possible because then I will need to implement lots of code in order to adhere to it, right? So I always try to choose the simplest scenario possible, okay, that I can solve pretty quickly, okay? So what would be the most simple scenario that we can think about in bowling? So in bowling, it would be pretty simple, right? If every player everywhere would always miss, always throw the ball into the gutter, so the score would always be 0, right? So let's do that. And as you can see, I'm not testing for methods or for stuff like that. I don't have the structure of the code yet. I am testing for business flows. So I would say that it should score 0 when playing a gutter game. Great. So what do I do first? I say const bowling equals require, and I'm going to require bowling. Now it doesn't exist yet, so it's a bit strange, right? But still, this is TDD also promotes something which is called outside-in programming, meaning I imagine that I have something and then I create it. It has many benefits, and one of them is the fact that the code becomes much more usable because the test is already using it. So it doesn't exist, I create it. Great. Let's go back here. And now I want to say, okay, so let's run a for loop 20 times, and let's do bowling.roll and roll 0, right? This is one of the APIs. Now, red-green refactor means that if something doesn't exist or doesn't work, we can see the squiggly line here, so I need to create it. So I'm now in red and I want to create it. So create method roll, which gets the numbers of pins. Sorry, pins. Okay, now I want to split my screen into two, so it will be convenient for us to see. So on the right, I'm going to have my production code. On the left, I'm going to have my test code. Okay? So let's start from here. Now what do I want to do? I want to say, okay, so let's expect that if someone called bowling.score in the end of the game, so the score should be 0. Okay. Now score doesn't exist, so let's create it. So let's create it, that's great, and let's run the test. So TDD is saying, okay, provide an example for something, right? Perhaps it will not work or doesn't compile, and then run it, see that you're in red, and then we're going to make it pass. So let's see what's happening here. Take some time. Okay, so it didn't work. Why? Because I expected 0, right? I expected to be 0 and received undefined. So this is pretty clear, right? Because I return undefined here, so of course it doesn't work. Now, what's the fastest thing I can do in order to solve it? Okay, without thinking about anything. So the fastest thing to do would be returning 0. Let's run the test. Now, you probably think that now, okay, but this is pretty silly. Okay, of course, if you return 0 and you expect 0, it will work, but you didn't do anything. So I agree, and TDD also agrees, but TDD also says, you know what, if it's so silly, so let's provide an example to why return 0 is not enough. Okay, and how do we provide an example? We actually write an additional test. So let's write an additional test. So this was very simple when playing a gutter game, so let's increase complexity just a bit. So I would say that it should score 20 when I'm playing a game with all ones. A game with all ones. Now imagine that I've rolled the ball and each time I've dropped one pin, so of course the score would be 20. This is very simple. So let's do that. So if I've rolled once and the expected would be 20, of course I'll run the test and they will fail, right? Because I return hard-coded 0 here. So let's try to make them pass. So first thing that comes in mind, okay, let's create a variable. Let's call it current score, and it will be 0. Now, whenever someone calls score, let's return current score. And whenever someone calls rolls, so let's calculate current score. So I would say current score plus equals the number of pins, right? And I want to change the order of the method because roll is called before score, and it's better for me to look at it this way, okay? Let's run the test. So I think that's going to work, but I'm starting to think that I might have an additional problem here, okay? Okay, so the tests are green, which is good, but do you remember that I told you that I don't want to handle with turns of different people, right? I want to have a module per player or something like that. And currently, because this is a module, so it exists only once in memory, so if I'll write an additional test here, and I'll probably do something like that, and say, you know what, let's see if it works again. So I'm guessing it will fail, right? Because it's already in memory. Current score after this game would be 20, and here it should be 40. So I'm not sure this design is actually good enough for me because I want to be able to create this kind of module per player, okay? Yeah, so that's not good enough. So I want to go back to green. Okay, let's run the test. And I want to make a change, okay? So instead of using a module here, I will actually use a class. So let's do that. So class bowling, okay? Class bowling would have what? It would have a constructor, and in the constructor I would have this dot current score, which will be 0. Great. Now I'm going to take these two functions inside the class. Great, and now of course I don't need this syntax of export function, and I don't need this syntax of export function. Great, and I actually don't need this let current score as well. And I do need to do this dot current score here, right? And this dot current score here. Great. And I need to export the module. So module export will be bowling. And that's about it here. So this is kind of refactoring, but it's not only refactoring because I'm changing a bit the behavior, right? Now I'm going to instantiate this one and not only have it as a module, but still it's the same behavior. So let's see. So here, instead of doing this require, let's take this outside and let's change the to capital B, and I'm going to say, you know what, let's let a bowling variable, and let's create a before each method, okay? The before each method is a method that actually runs before each test, okay? And before each test, I'm going to do bowling equals new bowling, okay? And now I don't need this bowling as well here. And let's run the test to see if it's working now. So I've done some refactoring here. So this is the idea of red-green refactor. I already have some code. I see some problem or something that I don't like. I refactor it and see that it is still working. So of course it's not working because yes is not defined naturally. Okay, sorry for that. Let's run it again. And once we're green, we know we're good to go. Great, so we're green and we're good to go. So this is actually much better for me. So red, green, and refactor. So now I should be refactoring, but I've already refactored my code. But that's a very important point in TDD, okay, in the realm that we're living. So test code is as important as production code, meaning whenever I'm doing refactoring, it also goes to the test code, okay? So I look at the test code and I think, how can I improve it? And actually I can, right? Because this piece of code here is actually duplicated for this piece of code. It looks exactly the same, right? So I want to extract it into a function and use the function, but I have some hard-coded values here. So I'm going to do it in two phases. First of all, I'm going to extract this 20 here, and I'm going to call it roles. I'm going to take this 0 here, extract it to a variable. I'm going to call it pins, and extract it out. Now I'm going to extract this into a method, okay? And the method is going to be roll many, okay? It's a helper method, a test method. Now I actually don't need these variables, the roles and pins, okay? I've just used them in order to help the IDE help me to do better refactoring. So I'm going to inline them back, okay? I'm going to inline them back and I don't need them. And now I'm going to take this line and I'm also going to invoke it in this test. By the way, this version of WebStorm doesn't recognize code duplication and replace them by their own, but they have actually promised that they will fix it soon. So I hope it will come soon. Great. Let's run the test again. Okay, let's wait. It takes a bit of time. Great, we should be good. Finally, we can continue. So we've tested for a gutter game. We've tested for a game with all ones. So what could be the next scenario? So as you can see, I'm not testing for structure of code, okay? So I would say that maybe we could continue and test a game that has only one spell. So it should actually calculate the score correctly when with one spell. Great. So how do I simulate a spell? I do the following. I would say bowling dot roll, and I want to roll, for example, a 7, okay? And then I want to roll a 3, right? That would be a spell because I've reached 10. And then let's roll an additional 3 so I can actually calculate the spare bonus. I remind you that the spare bonus is 10 plus the next roll, okay? So I've 17 rolls left to throw. I'm going to roll 0 in all of them to make it simple. Now, what's the expected score? So let's calculate. Okay, so for the first frame, I would get 10 plus bonus, which is 10 plus 3, it's 13. For the second frame, I will have this 3, and of course a 0 that comes from here. So it's 13 plus 3, which is 16. Okay, try to calculate for yourself before I explain it. It will help you see that you actually understand the rules of the game. Great. Now, will that work? Of course, it doesn't work. Okay, I'll run it in the background, but it doesn't work, right? I mean, I don't have any ability to calculate the spare bonus because I don't know what is the next roll in my current implementation. An additional thing that actually bugs me here is the fact that if I look at the code, I'm not sure that it's very good. I mean, I have a roll method, a roll function, okay, that what it does, it actually calculates the score. So I'm not sure this name is very good for the method. And I also have a score method, which actually returns the score. It's kind of a getter for this current score variable, right? So I'm not sure that's good enough. I want to do some refactoring here in order to meet the new requirement, which would be calculating something that from the next frame, right? So before I do that, TDD tells you, you know what, you want to do some refactoring, that's great. But before you do that, please start from green. So I'm actually commenting out this test, and I want to start from green because whenever I'm starting to refactor, I want to make sure that things are green and okay. And this way I will know that my refactoring didn't break anything, and that's very important, okay? So now I'm green, I'm going to do this. So I'm going to say this dot roles will be an array, okay? And whenever someone is rolling something, so let's do this dot rolls, and let's push the number of pins that were dropped. Great. Now, whenever I want to calculate the score, so let's create a local variable score, and I'm going to iterate over my rolls. Great. And now I'm going to do score plus equals rolls in I. This should work. Of course, it should be this dot rolls. Okay. And instead of returning current score, I'm going to return the local variable score. I think that should work, and also we keep like the history and the future by doing this dot rolls dot push. Great. Now I don't need this current score. I don't need this current score as well. Let's see if I didn't break anything. Now that's important. I've started from green. I want to see that I'm still green. Let's see. Okay, great. Still green. Now I allow myself to put the test here again. Now it's going to be red. Of course, I didn't do anything, but how would I implement it now? So the very basic thing to do would be, okay, so if this dot rolls in I plus this dot rolls in I plus 1, if it's already 10, so what might happen? So did you catch the error here? There was an error here actually, right? Because I might be checking the second roll in a specific frame and the first roll in the next one, okay? And this is not a spare. So this is still not good enough. So my design is still not good enough. I'm not sure that iterating over rolls is the right thing to do. So whenever my design is still not good enough, so still I want to start from green, okay? Commenting out the test, I know that I'm green now, and I want to do something a bit differently. I want to say, you know what, let's have another one, which will be the roll index. And I want to iterate over, instead of iterating over the rolls, I want to iterate in the context of frames. So instead of doing that, I'm going to iterate for 10 times, okay? And by doing that, I'm going to say the score should plus equals this dot rolls in current roll, so in roll index, plus this dot rolls in roll index plus 1. And then I'm going to take this index and increase it by 2. And this way I know that I'm in the context of frames. So let's see if that's working. I want to make sure that I've started from green and I'm going to be green again. Okay. And then I think that now I will be able to add the functionality. Okay, so I'm still green, finally adding this test, okay? I will run it to see that, of course, I'm still red, okay? And now I think that I know how to solve this, this challenge. So I would say, okay, I'm going to start writing while the test runs because I want to make sure that it's we're continuing in the correct pace. So of course it doesn't work. So I would say now if this dot rolls in all index plus this dot rolls in all index plus 1, and now I actually know that I'm in the context of the same frame, right? So if this happens, so score should be calculated as follows. It's 10 plus this dot rolls in all index plus 2, right? Because it's the next roll. Great. Else, I calculate it regularly. Okay, and either way, I need to increase the roll index by 2. Let's run the test to see if it works. Okay, let's see if we're finally green, and we're finally green. Okay, so that makes me happy. But now let's take a look at the code. I mean, the code actually becomes pretty complex. So I remind you, red, green, refactor. So now I should refactor my code. This is complicated, and this is complicated. And if I need to read it and understand what's going on, it's not that trivial. So someone would say, you know what, this if is very long, so you need to comment something. You need to say, okay, check if this is spare, right? So this is an ugly comment, okay? Comments are actually not that good practice, okay? We need to comment things only that we are unable to express via readable code. And here, this is not the case. So instead of this comment, I would actually take this entire condition, extract it to its own method, and I'm going to call it is spell. Now it's much more readable, right? Another thing that I'm going to do, I don't want to work with indices here. Okay, there's a clean code rule that actually says keep the same level of abstraction in your functions. So I'm going to go here and I'm going to extract it out as well, and I'm going to call it this dot spell bonus. Right? This is how it's calculated. And again here, I'm going to take this line and I'm going to say let's extract it out and call it sum of two roles. Great. So now actually the code is much better. Okay, when I read it, it's very, very readable and very easy to understand. Great. Let's run the test to see that I didn't break anything. Now try to think about what would be the next test. Okay, if this is going to be green, I've tested for a gutter game, I've tested for a game with all ones, and I've actually tested with a game with one spell. So what would be the next phase? So I'm guessing some of you said it would be a strike. Okay, so let's see how we can do that. So it should calculate the score correctly with one strike. Great. So how do I simulate a strike? So I'm going to do this, right? On the first roll, I've managed to drop all 10 pins, which is great. And now let's keep these 3 and 3 because I need both of them in order to have the strike bonus. I remind you, a strike bonus is the next 2 rolls, okay? And then I'm going to roll a gutter game until the end. So how many rolls do I have left? It's actually not 17, it's going to be 16, right? Because this 10 actually counts as 2 because on the first frame when I did a strike, so I didn't have an additional roll, right? So it counts as 2. So 2 here and 2 here, so 20 minus 4, it's actually 16. What's the expected score? Try to think for yourself, okay, before I let you know. So it's going to be 22, right? How? Because on the first frame I get 10 plus the strike bonus, which will be the next 2 rolls, so it's 3 plus 3. So 10 plus 3 plus 3, it's 16, right? On the second frame I have 3 plus 3, which is 6, so 16 plus 6 would be 22. Okay? Great. So let's continue. I think now it should be pretty obvious, right? I'm going to go here for my iteration. I'm going to say, you know what? If this dot rolls is already in the roll index is already 10, so what should I do? Sorry, not if. So what should I do? I should say that the score plus equals 10 plus this dot rolls where in the roll index plus 1, right? This is the next one, plus this dot rolls in roll index plus 2. And now what do I need to do? Now this is a bit tricky because the roll index actually need to be increased only by 1, right? Because I do not get to have a second roll in this frame because I've done a strike, okay? And of course I should add an else here, and this roll index plus equals 2 should now go inside the else's. Okay, let's run the test. So this red-green refactor thing actually causes me to refactor my code over and over again. So I'm always keeping my code tight and clean. And of course, I'm doing refactoring for the test code as I showed you in the beginning. So the test code also becomes quite clean. Great, so this is working. So refactoring, we already know the tricks here, right? I mean, we don't like these heavy conditions, so I'm going to extract them out. I'm going to say, let's call them is strike, right? And I'm going to take this code here and I'm going to say this is pretty complicated. Let's call it a strike bonus. Now, there's an additional thing that I want to do. Now, you all understand that I'm iterating in the context of frames, right? Because it's 10 and it's pretty obvious, okay? But there's another thing that I can do that will really help. I mean, instead of calling this variable I would change its name and I'm going to call it frame. And now everything is understood. Now we tend to always call I or J or K in the indices of a loop in case we're using this kind of for loop. But sometimes when we change the variable into something meaningful, it really, really helps. And I really, really like it this way. Okay, so let's run the test. Now, when I'm running a test, try to think, how do we continue from here? I mean, this is not that obvious, okay? Because Now we have 4 tests, okay? All of them actually cover the basics, right? And what do we do from now? Because we can do many, many things, right? We can actually say, let's run this kind of crazy game that has everything, right? Gutter, regular, spare, strikes, everything. We can write a game with all spares. We can test for a game with all strikes. We can do a combination. We can do many, many things, okay? So let's start from an edge case. Okay, let's do a perfect game. Okay, a perfect game is a game with all strikes. It will also cover the fact that we are doing strike in the last frame, that we need to have 3 rolls or something like that. Okay, so let's do that. So I'm going to duplicate this test, and I'm going to say that it should actually score 300 when playing a perfect game. So how do I simulate a perfect game? So I'm going to use my roll many method. Okay, I'm going to roll 12 times, okay, because this is how I can do it when I have strike every time, and I'm gonna strike each time, okay, which is great, and the expected, of course, should be 300. Now, try to think, will that work or not? What do you think? Some of you are saying yes, and some of you are saying no. I'm guessing, but let's try, okay? I'm gonna run this test. What is suspense? Let's see. Okay, already working. Interesting. So I've added a new test, but I didn't need to change any piece of code in order to make it pass. So that's interesting. What would you test next? Okay, so it's starting to get complicated. Should I test a game with all spells? Should I should I create a combination or something? Now, I'll let you in on a small secret. Now, we're basically finished, okay? The small piece of code that we've just written here is actually what we need in order to calculate a bowling game. So we're done. Every test that we're going to add here is going to pass, okay? Which actually brings me to a question. Should I add more tests, okay? If I don't need to change any code, so should I add more tests? And it's a difficult question because people sometimes tend to say, why not? I mean, add some tests and then you will have a safety net. But that's not very accurate because every piece of code that I write, doesn't matter test of production, I actually need to maintain later on. So I want my test suite to be small but very powerful, okay? So this is one thing. But the second thing is that, okay, but I can't rely only on the basic cases. So I actually like the fact that I've added this perfect game here, okay? Because it's kind of an edge case. It's kind of a thing that helps me know that I've tested for more scenarios. So in the real world, maybe I would add something like a sanity test that will take some combination to see that things are working, but that's about it, okay? I'm very careful with adding more and more tests. Now, what do we think about the production code? I mean, if you imagine something when I've read the requirements, was it this way or was it something else? I'm not sure, but I actually like the production code. I think it's very, very concise. It's very, very expressive, okay, and very readable. Now, some people tend to say that if-else if is not very good because it is not closed for changes if you know the solid principles. But I would say that the bowling game has never changed. At least not that I know of, okay? So when the number of possibilities is closed, so we're actually good. So we basically finished the exercise. So I want to summarize several things, okay? So first of all, I want to thank you for participating and I hope you find it useful and interesting, okay? If you did, and I hope you did, I highly recommend on trying out the things that we've discussed on your project. It can be test first. If it's not test first, so try to go for business flows instead of unit test, okay? Try not to mock everything, okay? But if you find it too difficult, especially with test first, okay? So I highly recommend on practicing on code katas such as the one that I've just did, okay? It's very, very useful and very effective, and the effect of like muscle memory actually works. When you go later on to production, it really, really, really helps. Now, thank you very much, and feel free to contact me on any platform. Thanks again.